Hi everyone, I really hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. Question number 24. The flow diagram below shows the steps that a learner follows to convert Butte 1 in into Butte 2 in. Okay, the aim is to move from here to there. So the learner will do some changes to our compound. Let's see what is the flow diagram telling us. Okay, we are moving from Butte 1 in to form compound X, which is a major product. Okay, we are forming compound X, which is a major product. That simply means that we are adding something to our Butte 1 in. Are you together? It will be Butte 1 in. This compound X, since it has a major product, we can only form a major product that is a haloalkane. Haloalkane. So what happened here was just addition reaction. Okay, and then now from haloalkane we are moving to a compound that has an OH in terms of instead of a halide. So that simply means that for us to move from compound X to compound Z, we are substituting our halide with the hydroxide ion. So what happens here is substitution reaction. And the type of substitution reaction is called hydrolysis. Now guys, whenever you have to move from a haloalkane to an alcohol, just know that you are doing hydrolysis. Let me write there. That's hydrolysis. Okay, and then now we are moving from compound Z to Butte 2 in. Compound Z, guys, is saturated, but Butte 2 in is unsaturated. That simply means there was elimination that took place there. Elimination reaction, and the type of elimination reaction is dehydration. Yeah? Okay. Okay, I wanted to throw in the reaction conditions. Okay, let me just do that. For the dehydration, you will forever need a concentrated strong acid. That acid can either be H2SO4 or phosphoric acid. Okay, and then for hydrolysis, you need to have a strong base, a dilute strong base. It can be, let me not use a red color. Let me stick with green. The dilute strong base can be NaOH or KOH or lithium hydroxide. You can take any of these, but just know that they should be in ethanol, inside ethanol. Okay, you will obviously need mild heat as well for the substitution. Mild heat, and then from butene to haloalkane, this one is just this reaction over there. It's exothermic. I don't think you will require a catalyst nor heat because it's exothermic reaction. We need heat there as well. Okay, now let's answer the questions, guys. Yes, I did I did analyze the flow diagram, but I didn't get deeper into it. But obviously the questions will require me to be deeper. Okay, write down the structural formula for the functional group of but1ene. How do we see that we are dealing with an alkene? We must see a double bond between adjacent carbons. We must see a double bond between adjacent carbons. Okay, and then compound X is formed when but1ene reacts with hydrogen chloride gas. Name the type of reaction that takes place. We did say that we are substituting. This is substitution. Why am I lying? To form compound X, guys, it's addition, man. Because remember that we're moving from but1ene to a major product, right? But now let's see how will our major product be like, ne? We have but1ene. This is but1ene. Excuse me. I'm lazy to write the hydrogens there, ne? But let me do so just for safety, so that you won't get used to being lazy as well. In the meantime, Bantwana Bam, I hope you are subscribing. Adding this with HCl, we are forming a major product, ne? Please note that, guys, that there was an extra hydrogen there. Please note that, guys, whenever you are doing addition reaction, we will always follow the Markovnikov rule. Are you together? Whenever you are adding something that has a hydrogen, please note that your hydrogen will always be attracted by the carbon that has the most number of hydrogens. Are you together? So the addition reaction will happen in either one of these two carbons. Not in either one of these two carbons, rather, but in one of these in these two carbons. Are you together? So we don't know whether the hydrogen will go there or the hydrogen will go to the terminal carbon. But Markovnikov rule tells us that if we want to form a major product, the hydrogen will forever go to the carbon with the most number of hydrogen atoms. So the carbon at the terminal carbon has 2 hydrogens, and then the second carbon only has 1 hydrogen. So our major product will be like this. Together, the major product will be like this. The hydrogen will go to the terminal carbon since it has the most number of hydrogens, and then the chlorine will come over there. All right, together. So the IUPAC name of this compound will be 2-chlorobutane. Okay, so that's how you deal with addition reactions, guys. Ne? Write down the structural formula of compound X. We just did. Let me write it here. It's 2-chlorobutane. That's H, chloro. That's how, guys, are supposed to draw the structure, né? Okay, and then now you're told that compound X is converted to an alcohol, which is a compound Z, né? For us to move from haloalkane to alcohol, you will always the type of reaction, rather, it will be called hydrolysis reaction, né? It's a substitution reaction. This is a substitution reaction. And the name of this substitution reaction is called hydrolysis. It's called hydrolysis. Are we together? Okay, write down the name or formula of another reactant needed for this reaction. You will need to have a dilute strong base. Let me just choose sodium hydroxide. I've written 3 of the bases you can choose from over there. It's up to you now. But I've chosen a dilute sodium hydroxide. Okay, and then now compound Z is being converted to but2-ene in the presence of a concentrated sulfuric acid. Remember that I did say that for you to eliminate, you will either need a concentrated sulfuric acid or phosphoric acid. The examiner chose to use sulfuric acid, né? So not we'll go with it. Compound Z is converted to but2-ene in the presence of concentrated sulfuric acid. Is compound Z a primary, secondary, or tertiary alcohol? Compound Z is a secondary alcohol. Let me draw the structure of compound Z. We have CH3, we have CH with an OH over there, and then we have CH2 as well as CH3. I must just write your hydrogens over there. Okay, this is the structure of compound Z, né? And I'm saying this thing over here, this compound over here is a secondary alcohol. Why? Because this carbon, which has our functional group of alcohols, is just bonded to 2 other carbons. That's why it is a secondary alcohol. So compound Z is a secondary alcohol. Name the type of reaction that takes place. We are moving from compound Z. There's a presence of a sulfuric acid, né? Which is concentrated, by the way. Sulfuric acid acts as a dehydrating agent, and it also speeds up the reaction. Are you together? So what will happen here is that since we are using a dehydrating agent, that means we must eliminate water, H2O. Are you together? So I already know that this OH will be eliminated. So now I want to know which hydrogen will also be eliminated, this one or this one. Are you together? According to Zaitsev's elimination rule, it simply says that whenever you eliminate, you must eliminate a hydrogen compound, a hydrogen atom from the carbon with the least number of hydrogens. We can either eliminate from this one or this one, because these 2 carbons are the ones which are adjacent to the carbon that has a functional group. Are you together? So according to Zaitsev's, I must take this hydrogen here, because this carbon over there has the least number of hydrogen atoms compared to the one which is at the terminal carbon. So I'll simply form something like this, like that, né? I have eliminated this. Now this carbon over there only has 1 hydrogen. You can see that, and that carbon does not have the OH. It only has 1 hydrogen. We can also see that over there. So the IUPAC name of this thing will simply be but2-ene. But2-ene. Okay. What did they want us to do there? How? They never asked us this thing. But for your own knowledge, guys, whenever you eliminate, if ever you do elimination and you are supposed to remove a hydrogen atom, you will always remove your hydrogen from the carbon with the least number of hydrogen atoms, né? Okay, name the type of reaction that takes place. That's elimination. Elimination reaction. And the type of elimination reaction is dehydration, because we have a dehydrating agent over there. What's the role of sulfuric acid? To act as a dehydrating agent. Dehydration agent. or you can even say this thing over there, sulfuric acid, it speeds up the reaction because it is a catalyst, né? Okay, another learner discovers that but2-ene can be prepared using the following incomplete reaction below. Okay, we have compound X. Remember that, guys, compound X was our major product, né? And it was compound X was let me write the structural formula. It was 2-chlorobutane. This was compound X. Then we had our chlorine over there, né? And then there's something that will end up having but2-ene. We'll simply have but2-ene and the other two inorganic compounds, né? Okay, we can see that, guys, compound X is a saturated carbon. Together, it has single bonds between adjacent carbons, but now we are forming but2-ene, and it is no longer saturated. So which simply means that elimination took place over there. Are we together? So since elimination took place, for us to eliminate, if ever we have a haloalkane, we will always need a concentrated strong base. Are we together? My concentrated strong base, let me use sodium hydroxide, NaOH. Sodium hydroxide, NaOH. Okay, since you are forming an alkene, that means we must eliminate these two, and whenever we eliminate those two, we will simply form NaCl as well as water. All right, together. The OH and the Cl will switch places, and then now the OH will bond with this hydrogen over there to form water. So the type of reaction that took place there is just elimination reaction, and the type of elimination is just dehydrohalogenation. Okay, conditions needed for this reaction to take place: you need a concentrated strong base, concentrated NaOH, as well as heat. Okay, and then they want the formula of the reactant and the products represented by letters A, B, and C. Already we know that A is the concentrated strong base. So A is just the NaOH. B is your NaCl, and then C is water. That's how, guys, we're supposed to tackle this question over there. Question mark 24. Just stay tuned, guys. We have 9 questions left. Thank you for your time.